Okay, so we will going to discuss about the FET. FET means what is the FET? Field effect transistor. Field effect transistors. FET they will going to call or JFET. So junction field effect transistors. So in that one, what you are going to learn? So you will going to learn about the construction, working, and characteristics. So construction, how it is constructed. Okay, construction wise, you have say about the N channel FET and then P channel FET. It's a construction. And working wise, what you have see about that one, it's lungs, is the diagram of the lungs diagram and a balloon. So this is about that working lungs diagram and a balloon. And characteristics, the characteristics is similar as it is that one BJT. So BJT transistor characteristics, what is that one? Output characteristics same as it is. We're going to see about that one, excuse me. Okay, so this is about the three. So I will repeat again. Construction. Construction is nothing but N channel FET and P channel FET. N channel FET and P channel FET. So what is the N channel FET? So this is a FET, symbol of the FET. Okay, symbol of the FET. The FET is a symbol. It is denoted like that one only. It is a consist of the three terminal. One is a drain, source, and a gate terminal. Three terminal. Okay. So here is a classification. One is a N channel. Another one is a P channel. N channel FET and a P channel FET. As similar to the transistors. So arrow mark is outward direction or arrow mark is inward direction. If arrow mark is inward direction means N. N is called inward direction. If arrow mark is outward direction means it's a P channel. As it is, you will know about that one. Transistors. Transistor also arrow mark is outward direction. Similarly, transistor arrow mark is inward directions. Okay. So similarly, in that one based, we're going to go say, okay, I will going to shortly, we're going to recap about transistor also. So arrow mark is outward direction, arrow mark is inward direction. N inward direction means N, outward direction means P. Okay. So in front of that one, N is there. So P, N, P. So you will going to form, this is the N, P, N. You will going to transistor form like. So same arrow mark is inward direction. So N channel FET and P channel FET. This is symbol of the FET. That's all. Okay. The next one. Okay. So this is about the construction. Construction wise we're going to see. And further we're going to see about the construction wise. So you will going to make the diagram. Yes, this is the N channel as well as P channel developed. Okay, construction. You have see what is the N channel means the N portion is more. Okay. So N portion is more compared with the P channel. That's all. This is about the construction of the N channel, as well as you can say about the P channel. P channel means the portion of the P is more compared with the N channel. This is about the comparisons. Okay, you can say about this is N channel. So more okay, more space compared with the P. So N channel and P channel. That's all. So this is about the construction point of view. Second steps. First one we were seeing about the symbol. Then second one is this is a construction developed. Okay, so this is a layer. Okay, the layer, the both P layer is connected to that gate terminal. So this is step number 3. You can write. So both P layer is connected to the gate terminal, and then here is a body. Okay, N channel is a top and N channel is bottom. You will going to connect a drain and a source. Okay, there are 3 terminals. So drain and a source you got connected. That's all. So this is a part we are going to discuss about the construction. You want to know about the construction. Okay, construction part is over. Okay, then next one working. Will go to working means I said about that one. Okay, analogy means you will going to recap about the tap. So how the tap is working. Okay, that is based, it is working number 1. Then second one is a lungs diagram. Then third one is a balloon. Okay, these 3 is include for that working. I will coming back to the working later. Okay, so next one we're going to see about the characteristics. So characteristics wise, you have see that is a okay, as you were seen about that BJT. Okay, BJT means what? Transistor characteristics, output characteristics. Output characteristics is nothing but so output characteristics nothing but output current versus the output voltage. So output current versus output voltage you will going to draw, that is called the output characteristics. So BJT is a current control device. That's why input is the okay, current is applied. You know, okay, class A amplifier I have explained. The class A amplifier output characteristics I have drawn here. Output current versus the output voltage. Okay, a variation of the input of the current. So variation of the input current based, the output, okay, output is it will go to reflections. Output it will go to produce. Variation of the input current based, the output is changed. Okay, so this is called output characteristics. Similarly, you have see about the FET also same similar. Output characteristics similar. So what is that one? Output current versus the output voltage. So you know this is a FET symbol. Okay, this is a FET symbol. So here is a gate terminal, okay, drain terminal, and another one is a source terminal. So here what is the input? Input is this side is the input, okay, input, okay, and what is output? So this side is the output. So this is the output part. So the flow of current in the drain, so id current versus the here across the voltage, so vds voltage. So you will going to draw id versus the vds, that is called output characteristics. That's all. So this is about the characteristics of that FET. Same similarly, we are going to draw the diagram. Same similarly, you will going to draw the FET diagrams. Okay. So I will going to draw. Okay, one place I will going to draw. So yes, so here I will going to draw. Okay, output current you will going to draw. Okay, and versus the output voltage. So V are not output voltage versus the I naught. What is the output current denoted there? So FET symbols you should be draw. So drain, source. So drain, source, and the gate terminal. So this is the outputs I said. So output means flow of current here. So I drain current. So ID current. So output current is a ID. You can write it as an ID. And then okay, across the voltage you will go to voltmeter connected. So here you will going to measure the voltage, that is called output voltage VDS, voltmeter connected across that one VDS. Okay, the next one. Okay, the next one, what do I want to do? N channel, do I want to construction of the N channel? Do I want to work? Do I want to perform, or P channel do I want to perform? Okay, I want to perform the N channel. So I want to perform the N channel means VGS equal VGS less than 0 only you will going to apply. VGS equal to 0, VGS equal to less than 0. There are two cases you can take it. VGS equal to 0 you can do. Okay, VGS equal to 0 you can do. Okay, so case number 1 is a VGS equal to 0 you can apply. Case number 2 you will going to apply for VGS less than 0. Less than 0 means what? You will going to apply minus 1 voltage, minus 2 voltage, minus 3 voltage. So like you will going to apply. Okay, so that's all. Yeah, so VGS I'm taking for that N channel lesson working test. I will going to take I will take for that N channel lesson working test. Okay, now I will going to proceed. Okay, so what I will going to apply? So input side is a 0 voltage. 0 voltage means gate to source is connected to 0 voltage, no potential difference, no potential open difference. Otherwise you will going to connect the one source. Okay, source, okay, you will going to connect it, but 0 voltage only you are going to apply. Nothing, you didn't apply any voltage. Then okay, you will didn't apply. Okay, then what happened next? So drain to the source. So drain to the source I will going to apply. So drain to the source I will going to apply the source. So if I will going to apply the source on the drain, so drain to source means what happened? So here is a output current versus the output voltage is a linearly increase. It will going to increase linearly, it will going to increase. Okay, and after that what happened? It is the output current is saturated. Okay, that one is a working operation. I will going to coming back to the working operations. Just I will tell about the output characteristics. So linearly increase, that is called ohmic region, and then after that is saturate region, then breakdown region. That's all. This is called VGS equal to 0, then VGS equal to minus 1 you can draw, and VGS equal to minus 2 you can draw, and VGS equal to minus 3 you can draw, and VGS equal to minus 4. It is a almost cut off regions. So this is a characteristics is nothing but output characteristics. Output characteristics. Okay, don't worry, I will be teach about this concept again. Okay, so this is about, so far I have explained about this point number. Okay, so output characteristics explained. Okay, then okay, then next to one more point, basic introduction you will going to complete it. So FET is a voltage control device. What is a voltage control device? Input is a, you will going to apply the voltage, 0 voltage, less than the 0 voltage. If it is N channel means less than the 0 voltage you will going to apply. If it is a P channel means greater than 0 voltage apply. So based on the input applying the voltage, the output it will going to perform. That's all. The output of that one it will going to conduct or off. So output is totally depend with respect to the input voltage. Input voltage. So it is a voltage phenomena device. That's all. Then next one, terminals. How many terminals? Gate, drain, source. It's consisted of the 3 terminals. Then types of the FET means you can ask, if they are asking, you can say about the N channel FET and the P channel FET. What is the N channel? The arrow is inward direction. P channel is arrow is outward direction. Okay, FET is a unipolar device or bipolar device. FET is a unipolar device. So either you can use the N channel or P channel at a time. Either you can use the N channel means electrons, or P channel if you are using selected means that is a holes. That's all. Then output characteristics means what? Output voltage versus the output current. So you will going to draw about that one. So that is about output characteristics. This is a basic introduction about the FET. And further we'll going to, so far I have explained about constructions and then introduction about that one, and characteristics I have touched. So then what we are going to further we're going to discuss means we're going to see about the working of that FET. So working of the FET and the characteristics we're going to see. Okay. Okay. So here one more point you will going to keep your mind. So whether you will going to conduct a test for N channel or P channel. If you are going to conduct a test for N channel means, so input voltage is less than 0 voltage you can apply. If you are going to conduct a test for that P channel means just opposite, input voltage greater than 0 you will going to apply. This is one of the major important point. Okay, so N channel I will going to consider. N channel if I have considered means this is the N channel. So most of the portion is covered by the N, that's why it is called the N channel. So I will going to apply the input voltage. What I will going to apply for input voltage less than 0 voltage as an apply for the two case. Okay, I will go ahead on that further. This is a working. Okay, so working what you will going to see. Once again I will going to tell about the analogy. So working in step number 1. So you will going to, okay. So working step number 1 you will going to you want to know about that one, step number 1. So it is very simple, tap. So how the tap is working you want to know. So, and then second one is a lungs diagram, and the third one is a balloon. Okay, these three you want to know about that one. This is a combination of three is called working. So we're going to see about that working on that one. Okay. Yeah, so this is a differentiations about the N channel and a P channel. So most portion is covered. Yeah. Then next one. Okay, so N channel we'll going to further we'll going to take about, further we'll going to proceed. Okay. Okay, so you have see how many junction means there are two junction. Here is one junction PN junction, here is another junction PN junction. There are two junctions. So once the two junction means, okay, you will going to give the power supply. If you're going to give the power supply to drain to the source, if you are going to give means the outside of the P junction there is a layer is created, that is called a deflection layer. Deflection layer is created outside, okay, outermost of the outer layer of the P layer. Okay, that is a two deflection layer is created. Okay, then next one. Okay, so you will going to, okay, apply the voltage 0 voltage less than the 0 voltage, that is the working operations. Okay, and yeah, so if you're going to apply the voltage, what will happen, that one you will want to know. Okay, so if I will going to apply the voltage between here, so if I will going to apply means, so electrons is created in the source side. Okay, electrons is start to move towards the up direction, towards up direction, or you can drains directions. Then drain side what is that means, drain current. Drain current, that is called conventional current. Conventional current is a, once you will going to give the source, conventional current is start to flow in the downward direction. That's all. So that is a point you want to know. Okay, yeah. So working, now we will go ahead on the working of the JFET. So it is simple to understand about the tap, how the tap is connected. Okay, overhead tank and connected to the tap, and if tap, if you are going to open the valve, that water is coming outside. It's water is nothing but electron. You can think about electron. So here is a sink. Okay, sink is there. Sink means what is a sink in your kitchen room? Okay, there is a sink. Okay, tap and then connected with the sink. So the outer side, I mean, you will going to wash your hand on the sink. Okay, so that is called a sink. Okay, so this is about the tap. Okay, it's a, you see the water is a potential. Okay, when force of the water is coming outside means there is more gap. I mean potential difference is high. Okay, here and there, then force it is coming. So that is a potential differentiation. So similarly, gate to the source is a potential differentiation. Okay, gate to the source is a potential differentiation, VGS. Okay, then here is what is a control valve. Control is a valve. Okay, here is a gate is a control. Gate is a control, on and off, close and open. Okay, so like electron is coming. So electron is coming here. So electron is it will go to generator. So electron where it is coming, you can say either tank, or from the, this is output of the electron is coming from the tap. Output is electron is coming. So here is the source is the electron is coming. Source is a electron is coming. So who is collector? So he is collecting the electrons. So he is collecting the water. Sink is collecting. Okay, similarly sink is nothing but a drain. So that's all. So how the tap is operated? So here is the water is coming, and then here is a valve is, you will going to open the valve or close the valve, and the sink it will going to collect the waters. So he is supplier and he is a collector. That's all. Okay, 1, 2, 3. So this is the base, this is the FET is working.